Hello guys, welcome once more to Prepclass Physics class online, and my name is Tutor Dami. In this video we shall be looking at Waec Physics 2016 question number 36 to 40, and we shall be dealing with the questions. Now don't forget that if you learn anything from this video, click on like button. We have loads of content that will further help you to better understand physics and simplify it. And let's get to the question now. 36. The electric meter in houses measures energy consumed in what? Now, what is the unit of energy? When PSCN or the Power Holding Company of Nigeria come to your house to give you bill, in what unit do they give you? Is it in kilowatt hour, volt, ampere, coulomb? Now, you might want to check it out, but actually the answer is very simple. It's just kilowatt hour, because the PSCN company calculates the amount of power you use in kilowatts, and they check the amount of time you have consumed it. So Mrs. Kemi might use the electricity for 20 hours in a month. That's not possible. I can say 150 hours in a month. Okay, now they will calculate the hour multiplied by the power. The power is always in kilowatts, so it is kilowatt hour, not volt. Volt is for voltage or for potential difference. Ampere is for current, and coulomb is for charge. Now those ones are totally off what they calculate for our electricity. So you want to check on your bill next time you see it. Now let's check out number 37 now. A man and his friend has mass 70 kilograms and 60 kilograms respectively. If they were seated 1 meter apart, calculate the gravitational force of attraction between them. Now when you hear the word gravitational force of attraction, does any formula come to mind? That is called Newton's law of universal gravitation, and that applies to this formula. Fg equals gm1 m2 over r squared, right? That is the formula for gravitational force on any question, any day, any time. Anything gravitational force is this formula. It says gravitational force equals g, which is gravitational constant, multiplied by the mass m1 multiplied by the mass m2 over the distance r squared. Okay, now let's put in the g. Gravitational constant is 6.6 times 10 to the power minus 11. Then my mass m1 is 70, my mass m2 is 60 over the distance r squared. That's r squared, and that's 1 meter squared. 1 square is still 1, and that means it is not really applicable. So 1 square is 1. It's not really going to affect my answer. So therefore, I'll work on the numbers now. 6.67 times 10 to the power minus 11. 70 times 60 is 4,200. So multiply the number to the number. 4,200 times 6.67, that will give you 28,014 times 10 to the power minus 11. I don't multiply to 10 first, so that will become number to number. That's 28,014 times 10 to the power minus 11. Now put it in standard form. That means that the point will move from here 1, 2, 3, 4. That's to the back of 2. 4 steps. So that means you will remove 4 from this. You will add 4 to this minus 11, and that will give you minus 7. That will become 2.8 times 10 to the power minus 11, and that is my answer, making option B the correct answer for the gravitational force. Don't forget, the most important part is the formula Fg equals g m1 m2 over r squared, and that is the formula for gravitational force any day, anytime. This is called the Newton law of universal gravitation. This is the equation that it batted, and that is the answer for this question. Now let's go on to the next question, number 38. The potential difference across a parallel plate capacitor is 10 to the power 3 volts. If the distance between the two plates is 10 centimeters, calculate the magnitude of the electric field strength between the plates. Now when you hear the word electric field strength, it has a formula under electric field. Now do you remember the formula? Now if you don't remember, I'll remind you. This is the formula for electric field. E equals F over Q, or E equals V over D, or E equals Q over F pi E naught times R squared. These are the formulas for electric field. Now some of these formulas we might want to pen them out. Like I always have a formula book where I put down all the formulas I learn per time. And these formulas are all important. That means question can come from any of them. So you must be conversant with all of them, because formulas are keys to question. Now the one that applies to this question is this one, V over D. For one reason, the question spoke about potential difference V, and it spoke about distance D. So the formula says calculate the magnitude of the electric field strength and that is, I'll be using this v over d. So now my v in the question is 10 raised to the power 3, and my d is my distance. It is given to me in the question between two plates. Distance between two plates is 10 centimeter, but centimeter is not the unit of distance. It is a trap. Now, whenever they give you distance in centimeter, you must change it to meter, and that means you must multiply by 10 raised to the power minus 2, and that's what I have here. 10 raised to the power minus 2 here, and that's 10 times 10 raised to the power minus 2 meter. I've converted it to meter. That's how you change centimeter to meter. So it must be meter. If you use 10, you failed it, because meter distance is not measured in centimeter but in meter. So I have my PV or my V or my potential difference as 10 to the power minus 3, then my distance as 10 times 10 to the power minus 2 in meter, not in centimeter, and that will give me 0.1 below. So that I have 10 to the power 3 over 0.1, and that will give me 1000. And that is also, you can also write it as 10,000. You can also put it as 10 to the power 4 volts meter per meter. 10 to the power 4, because 10,000 has 4 zeros. That will be 10 to the power 4 volt meter, and that is my answer. It can also be written as 1 times, actually that one is not really affecting it. 1 times 10 to the power 4 volt meter, and that's the way the answer was placed. So that's the answer is 1 times 10 to the power 4 volt meter, and that is the answer. Now, most importantly, don't forget the formula for electric field strength. It is E equals F over Q, or V over D, or Q over 4 pi E naught R squared, depending on the one you are asked per question. That tells the one you will use. In a later video on electric field, we will later properly explain how these formulas are derived. But for now, for the sake of the past question, you just have to get acquainted with them and be able to apply them. And that settles this question. The answer is option A. Let's check number 39. There are more than one ways to charge a metal. Now, one of such way, we have different methods, but actually one of such way is induction. We can also have many ways by electricity method, that's under magnetism, how to create a magnet. Induction is one of such way, but this question is asking that when you rub a body against the against the second body, and the body gets charged, what is the meaning of that process? Is it induction, friction, conduction, or convection? Now let's check out the meaning of these guys. Now, induction is the process of charging a neutral body by bringing it close to a charged body, and that means induction is our answer. What I mean is that induction is how you charge a metal, or you charge a metal. That's, you make a metal to become a magnet by bringing it close to a magnet. That is, if you bring a metal close to a magnet for long, the metal will become charged also. That process is called induction. It's like, I always tell people that if you walk too close to somebody who is negative, you also will become negative. That's, if you have a friend that is not brilliant and you walk too close to him, you might become also dull. I've seen that happen many times in real life before. So also that happens, that is an example of induction, transference of charge. So if a person is white and you walk with somebody who is red, the red on the person will rub off on you and you become red at last. So that is also induction, bringing a chargeless body near a charged body. The chargeless body will finally become charged. That is induction. Then we have heat transfer from a hot body to a cold body, like when you touch the top of the pot, the heat transfer of your pot. The heat transfer from the cover of your pot to your hand, and you get burnt by conduction from a hot body, from the cover of the pot to your hand to the cold body, and it burns your hand. That's by conduction. Convection is heat transfer by the movement of fluid. Convection is what you see in a cool room. The heat transfer, like if outside is cold and you put on the warmer, that's if you put on the warmer, the heat circulates within the house. That is an example of convection. Or if you are boiling water, the heat circulates within the water. That is an example of convection. It does not transfer it by touching, but by fluid or molecules, and that's convection. But friction is the force that opposes the relative motion of a body over another. The force that opposes motion of one body over another is friction. Like you have your leg on the ground. The force that opposes your movement on the ground is friction. So the answer is not conduction, it's not convection, it's not friction. The simple answer to the simple question is just induction, the transfer of charge by bringing a chargeless body near a charged body, and the answer is simple induction. And that is my answer for number 39, induction. Let's check out number 4, the last one for this video. Which of the following factor does not affect the EMF of a primary cell? EMF means electromotive force, right? What do you think cannot change the EMF of a cell? Is it size, internal resistance, operating temperature, or duration of usage? Do you have any idea which one might be right? Now you can make a guess which one might be right. Now actually the EMF of a cell is this is a cell. You can see these cells, these are all primary cells. They are all primary cells. That means they are non-rechargeable cells. Now the EMF of a cell is affected by one, and here it is. Let me show that to you. The answer is size, and I'll tell you why. The reason is because no matter how big the cell is, no EMF has to do with the work done between the terminal of the cell. That's, every cell has a positive and a negative terminal. Now between the positive, that's what I'm saying is that you have these cells now. This is positive. The lower part is negative, right? This is positive and this is negative. The work done between these two terminals is called the EMF. Now, which one affect? Now, does the size of the cell affect the EMF? Does the size of this battery affect the work done? No. The only one that does not affect the work done is the size. It doesn't matter how big the battery is. Normal work will still be done between the terminals. In the formula of EMF, internal resistance is a function, and that's why the EMF is affected by the internal resistance of the battery. Then we have the temperature. The temperature, when the battery gets hot, it affects the work done by the battery, right? So an overheating battery will be affected, but the size does not really affect the work done. It is the heating, the temperature of the battery affects the work done by the battery. Then the duration of usage. If you overuse the battery, the work capacity of the battery will get lower, but the size of the battery does not affect the work done by the battery, because no matter how the size, normal work will still be done by the battery. The normal rating of work the battery is supposed to do, the battery will still function within that size of work. So the size does not really affect the work done by a primary cell, and that is the answer to the question. Don't forget, if you learned something from this video, to click on like button. We have more content to share with you that will better help you understand physics. Until we see next time, guys, take care of yourself and bye for now.